A totally enclosed fan-cooled, or TEFC, motor is designed with an enclosure that prevents the free exchange of air between the inside and outside of the motor. This type of motor is very suitable for outdoor use. The construction of a TEFC motor incorporates several key features that contribute to its protection against environmental factors. Firstly, the motor's frame is typically made of cast iron or steel, providing a robust and durable enclosure. This enclosure is designed to prevent the ingress of solid objects such as dust, dirt, and debris, as well as liquids such as rain and snow. Secondly, the motor's end shields are tightly sealed to the frame, further preventing the entry of contaminants. These seals are often made of rubber or other flexible materials that can withstand temperature variations and maintain a tight fit over time. Thirdly, the motor's fan, which is used to cool the motor, is located inside a shroud or cover that protects it from the elements. This shroud also helps to direct the airflow over the motor's frame, maximizing cooling efficiency. Fourthly, the motor's bearings are typically sealed and lubricated for life, preventing the entry of contaminants and reducing the need for maintenance. Finally, the motor's windings are often coated with a special insulation material that protects them from moisture and chemicals. The totally enclosed fan-cooled designation indicates that the motor is cooled by an external fan that blows air over the motor's frame. This fan is typically located at the non-drive end of the motor and is driven by the motor shaft. The fan is enclosed within a shroud to protect it from the elements and to direct the airflow over the motor's frame. The cooling air is drawn in through openings in the shroud and exhausted through other openings, creating a flow of air that removes heat from the motor. While the enclosure prevents free exchange of air from the outside, it is not entirely airtight. A small amount of air is exchanged. It is designed to prevent the entry of dust, water, and other contaminants that could damage the motor's internal components. The protection against environmental factors makes TEFC motors well suited for outdoor applications where exposure to the elements is a concern. They are commonly used in pumps, fans, compressors, conveyors, and other equipment that are located outdoors. The TEFC motor is preferred over an open dripproof or up motor in exposed settings because an ODP motor is designed with openings that allow for the free exchange of air between the inside and outside of the motor. While these openings allow for efficient cooling, they also allow for the entry of dust, dirt, moisture, and other contaminant. The ODP motor is designed to prevent dripping liquids from entering the motor, but it is not protected against splashing or spraying liquids. Therefore, an ODP motor is not suitable for outdoor applications where it may be exposed to rain, snow, or other forms of moisture. In addition to their suitability for outdoor use, TEFC motors offer several other advantages over ODP motors. Firstly, they are typically more energy efficient as the enclosed design reduces windage losses. Secondly, they are quieter in operation as the enclosed design reduces noise emissions. Thirdly, they require less maintenance as the enclosed design protects the internal components from contamination. However, TEFC motors are typically more expensive than ODP motors. The selection of a motor for a specific application depends on a variety of factors, including the environment in which the motor will be used, the load that the motor will be driving, and the desired level of energy efficiency. In general, TEFC motors are a good choice for outdoor applications or in environments where there is a high level of dust, dirt, or moisture. Understanding the National Electrical Manufacturers Association, or NEMA, standards for motor enclosures can help in selecting the right motor for a particular application. NEMA defines different enclosure types based on the level of protection they provide against environmental factors. For example, a NEMA 1 enclosure provides protection against falling dirt, while a NEMA 4 enclosure provides protection against splashing water. A NEMA 4X enclosure provides protection against corrosion. In addition to the enclosure type, the motor's nameplate also provides information about its horsepower, voltage, amperage, speed, and other important characteristics. This information is essential for selecting a motor that is compatible with the equipment it will be driving. Proper installation and maintenance are also important for ensuring the reliable operation of a TEFC motor. The motor should be installed in a location that is well ventilated and free from obstructions. The motor should also be protected from excessive vibration and shock. Regular maintenance should include inspecting the motor for signs of damage such as cracks or leaks, and cleaning the motor to remove any accumulated dirt or debris. The motor's bearings should also be lubricated periodically according to the manufacturer's instructions. When selecting a TEFC motor for outdoor use, consider the specific environmental conditions to which the motor will be exposed. In areas with high levels of humidity or salt spray, a motor with a corrosion-resistant enclosure may be necessary. In areas with extreme temperatures, a motor with a special insulation system may be required. It is also important to consider the motor's duty cycle, which is the amount of time that the motor will be running. For applications with frequent starts and stops, a motor with a high starting torque may be necessary. Finally, it is important to select a motor that is properly sized for the load it will be driving. An undersized motor will be overloaded, which can lead to premature failure. An oversized motor will be less efficient and may not provide the desired performance. Consider the ingress protection, or rating of the motor. The IP rating is a two-digit number that indicates the level of protection that the enclosure provides against solid objects and liquids. First digit indicates the level of protection against solid objects, ranging from 0 to 6. A rating of 0 means that the enclosure provides no protection against solid objects, while a rating of 6 means that the enclosure is dust tight. The second digit indicates the level of protection against liquids, ranging from 0 to 8. A rating of 0 means that the enclosure provides no protection against liquids, while a rating of 8 means that the enclosure can withstand prolonged immersion in water. For outdoor applications, an IP rating of I55 or higher is recommended. This means that the enclosure is protected against dust and water jets. Consider the motor's insulation class. The insulation class indicates the maximum temperature that the motor's windings can withstand without being damaged. The most common insulation classes are A, B, F, and H. Class A insulation is rated for a maximum temperature of 105 degrees Celsius or 221 degrees Fahrenheit. Class B insulation is rated for a maximum temperature of 130 degrees Celsius or 266 degrees Fahrenheit. Class F insulation is rated for a maximum temperature of 155 degrees Celsius or 311 degrees Fahrenheit. Class H insulation is rated for a maximum temperature of 180 degrees Celsius or 356 degrees Fahrenheit. For outdoor applications, an insulation class of F or H is recommended. This will ensure that the motor can withstand the heat generated by the motor itself and the heat from the sun. Select a motor with the appropriate voltage and frequency for the power supply. Motors are typically designed to operate at a specific voltage and frequency. Operating a motor at the wrong voltage or frequency can damage the motor. Common voltages are 120 volts, 208 volts, 240 volts, 277 volts, 480 volts, and 600 volts. Common frequencies are 50 Hz and 60 Hz. Check the motor's nameplate to determine the voltage and frequency requirements. Choose a motor with the appropriate horsepower rating for the load it will be driving. The horsepower rating is a measure of the motor's ability to do work. The horsepower rating should be high enough to handle the load without overloading the motor. Overloading a motor can damage the motor and shorten its lifespan. Consult with a qualified electrician or engineer to determine the appropriate horsepower rating for your application. Use a motor with overload protection. Overload protection is a safety feature that protects the motor from damage due to excessive current. Overload protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds a certain level. This will disconnect the power to the motor and prevent it from overheating and being damaged. Be sure to use the correct size overload protection device for the motor. Install the motor in a well-ventilated location. Motors generate heat when they operate. If the motor is not properly ventilated, the heat can build up and damage the motor. Install the motor in a location where there is plenty of air circulation. Do not block the motor's ventilation openings. Keep the motor clean and free of debris. Dirt, dust, and debris can accumulate on the motor and prevent it from cooling properly. Clean the motor regularly with a vacuum cleaner or a brush. Be sure to disconnect the power to the motor before cleaning it. Lubricate the motor's bearings regularly. The motor's bearings need to be lubricated to reduce friction and prevent wear. Follow the manufacturer's instructions for lubricating the bearings. Use the correct type of lubricant. Check the motor's wiring regularly. The motor's wiring can become loose or damaged over time. Check the wiring regularly for signs of wear or damage. Tighten any loose connections. Replace any damaged wiring. Have the motor inspected by a qualified electrician regularly. A qualified electrician can inspect the motor for any potential problems. They can also perform preventative maintenance to keep the motor running smoothly. Follow the manufacturer's recommendations for preventative maintenance. Always disconnect the power to the motor before working on it. This will prevent electric shock. Be careful when working around rotating parts. Rotating parts can cause serious injury. Keep your hands and clothing away from rotating parts. Wear safety glasses when working on the motor. Safety glasses will protect your eyes from debris. Use caution when lifting the motor. Motors can be heavy. Use proper lifting techniques to avoid injury. Get help if you need it.